This lecture, let us see superposition theorem. Superposition theorem is used to analyze the circuit. So it is, but all theorems are used to analyze the circuit. Then what is the special of superposition theorem? When the circuit is contained with more than one source, then this superposition theorem is used. So when circuit is with more than one source, it is used. What superposition theorem states that? Let us see. Statement of superposition theorem. The superposition theorem states that if you are with any linear or bilateral two-terminal network containing more than one source. So first point, any linear or bilateral two-terminal network consisting of more than one source. Then more than one source means what happen? So the total current flow through particular part of the network, then it is equal to sum of currents or voltage that would has been produced by each source taken separately and replacing other sources with their internal resistance. So if we have with more than one source, then the total current or voltage, the total flow of current or voltage at any part of network is equal to algebraic sum of currents or voltage that would has been produced by each source taken separately. So sum of that currents or voltage that would has been produced by each source taken separately. And what about the other source? The other sources are replaced with their internal resistance. The other sources are replaced with their internal resistance. So you may get confused. What is internal resistance of that other sources? If you have voltage source, we has been with the two type of sources, that is voltage sources and current source. Then internal resistance of voltage source is R internal equal to 0 and internal resistance of current source is infinity. So if we have internal resistance like this, for 0 internal resistance we have to replace with the short circuit, and if we have with the infinitive internal resistance, then there we place it a open circuit. So now voltage source is replaced with short circuit, and current source is replaced with open circuit. Simply seeing the statement, you may not understand the concept clearly. Let us understand the concept in more detail by solving one problem. What is the question? By using superposition theorem, find I in the circuit shown in the figure. So we should find this current. So from statement of superposition theorem, what superposition states the total flow of current or voltage. Here he asked to find a current. So the total flow of current is equal to algebraic sum of current or voltage. So now algebraic sum of current that has been produced by each source taken separately. So we are taking first 20 volt source and second 5 amp source, and replacing, if we take 20 volt source, we are replacing this 5 amps with internal resistance. Simply we are open circuiting this 5 amp source. Again, when we are taking 5 amp source, then we are short circuiting this 20 volt source. Now draw the circuit with replacing other sources with their internal resistances. So now draw the circuit with replacing the other source with their internal resistances. So first taking 20 volt source and 5 amp source is open circuited. So if we draw this, the circuit is look like this. Again, if we take 5 amp source, then 20 volt source is replaced as a short circuit. So if we draw the circuit by this, the circuit look like this. After redrawing the circuits is look like this. So now here I am finding I in the circuit and I am finding I in the circuit. So I am using mesh analysis, naming this current flowing in this loop is I2. Here if you observe, this is not a loop, so I am not considering this as loop. So if we apply mesh analysis on in loop 2 or I2 loop, we get 5 plus 3 8 I2. Here this I2 touching first negative terminal of 20 volt source, so minus 20, which is equals to 0. Then 8 I2 equals to 20. I2 is equals to 20 by 8. Similarly, here also I am going to find the I. So applying mesh analysis and naming this loop as I3 and current flow in this loop as I4. Now apply mesh analysis in loop 3 or I3 loop. We are going to get 5 plus 3 8 I3, and this I4 also affecting on I3 by this 3 ohms resistor. So minus 3 into I4, which is equals to 0. Again apply mesh analysis on loop for or I for loop. Here this 5 amps current source is making trouble in writing the loop equation, so here loop equation is won't work. Now I am taking branch current. So now I am taking branch current such as this 5 amps in this direction, and I4 is coming opposite to the direction of 5 amps. So I4 is equals to minus 5, and if you substitute this in equation number 1, we get I3. So 8 into I3 minus 3 of minus 5, which is equals to 0. 80 I3 is equals to plus 15 equals to 0, and I3 is equals to minus 15 by 8. If we observe here, the current I, let us name this as I dash, this as I double dash. Here I double dash is equal to the current passing, the I3 passing along with the I double dash direction, and current I4 passing opposite to the direction of I double dash. So I3 minus I4, which is equals to I double dash. What is I3? I3 we got I3 as minus 15 by 8, and minus what is I4, minus of minus 5, which is I double dash, nothing but which is equal to, now I double dash is equals to 25 by 8. Again here I dash is flowing like this, and I2 also flowing like this. So I dash is equals to I2, which is equals to 20 by 8. So I am considered I dash and I double dash in this direction. So I is equals to, now therefore now total current or I flowing through this branches, or now total current or I flowing through these branches, I is equals to I dash plus I double dash, which I is equals to 20 by 8 plus 25 by 8, now which is equals to 45 by 8. 45 by 8 is equal to 5.625. So therefore I is equals to 5.625 amps.